Bismillahirrahmanirrahim. Assalamu alaikum everyone. Dear students, welcome back to our regular chemistry first paper online class English version arranged by KPB School and College. This is Irene Parveen. Today I will discuss another important topic under chapter 3, which is relation between periodic properties and chemical bonding. The title of chapter 3 is Periodic Properties of Elements and Chemical Bonds. Now I am going to discuss chemical bond. The force of attraction between the interacting atoms leading to the stabilization of a molecule is called chemical bond. Here two things is very important. One is force of attraction and another is stabilization. That means the chemical bond is the process of getting more stable electronic configuration by those atoms similar to their nearest inert gas elements, either by donating or accepting electrons or sharing of electrons. Chemical bonds are of mainly four types: ionic bond, covalent bond, coordinate bond, and metallic bond. Today, I am going to discuss ionic bond and covalent bond elaborately. Now, I would like to discuss ionic or electrovalent bond. The ionic bond is a bond which is formed by transfer of one or more electrons from one atom or radical to another. Actually, ionic bonds are formed between metals and nonmetals with the transference of electron. Metal give up electron and nonmetals accept that electrons to obtain stable electronic configurations, duet or octet. As a result, nonmetal atoms become positive ions and as a result metal atoms become positive ions and nonmetal atoms become negative ion. Then the oppositely charged ions get bonded by electrostatic force known as ionic bond. For example, sodium chloride, formation of sodium chloride. Here, sodium give up one electron. Look at the figure please. Here, sodium give up one electron and become positively charged. On the other hand, chlorine accept this electron and become negatively charged. Then these oppositely charged combine together by electrostatic force and form sodium chloride, and this is ionic bond. And another information is important here, which is if the difference of electronegativity of two elements is very high, that is greater than 1.5, then through the transference of electrons in the outermost shell of the two elements, ionic bond is formed. Here the electronegativity of sodium is 0.9 and electronegativity of chlorine is 3.0 and their difference is 2.5. 1, which is greater than 1.5. So, one electron is lost by sodium, and that electron is accepted by chlorine to form ionic compound sodium chloride. Next, I am going to discuss covalent bond. The chemical bond which is formed between two atoms by sharing of electron pair coming equally from both the non-metal atoms is called covalent bond. Here, two things is very important, which is sharing of electrons, and this type of bond forms between non-metal atoms. For example, when hydrogen and oxygen atoms combine to form covalent water molecules by sharing of electron pair, we can see the uh, outermost shell of oxygen contain 6 electrons, whereas hydrogen outermost shell of hydrogen contain only 1 electrons. Between the 6 electrons of oxygen, there are only 2 non-pair electrons, and these 2 non-pair electrons sharing their electrons with another with hydrogen atom, and thus they form covalent bond and covalent compound water. And another example is methane. Carbon has 4 electrons in its outermost shell, and hydrogen has only 1 electron in its outermost shell. And to fill up octet, carbon needs more 4 electrons. So here carbon share his 4 electrons with 4 hydrogen atoms and form covalent molecules methane. And this covalent compound is formed when the electron negativity difference between two atoms is less than 1.5. Then the elements do not lose electrons, rather they share electrons to form covalent bond. For example, HCl. Here the the difference of electronegativity of chlorine and hydrogen atom is 3.5 minus 2.2 equal to 1.3, which is less than 1.5. So chlorine and hydrogen will form covalent bond by sharing one electron from each atom. Now, I would like to discuss single, double, and triple bond. At first, single bond. A covalent bond formed by mutual sharing of one pair of electrons is called single bond. And a single bond is represented by a small line. Single bond is represented by a small line like this. For example, formation of methane. Here carbon has 4 electrons. Carbon has 4 electrons in its outermost shell. Thus, it requires 4 more electrons to acquire a stable noble gas configuration. On the other hand, hydrogen has only 1 electron in its outermost shell and requires 1 more electrons to complete its outermost shell, that is, to acquire helium configuration. And here single bond is formed between carbon and hydrogen. Now, double bond. The bond formed between two atoms due to the sharing of two electron pairs. Due to the sharing of two electron pairs is called double covalent bond or simply a double bond. It is donated by two small horizontal line. Look here. Horizontal line. Look here. Double bond is represented by two horizontal line drawn between the two atoms. For example, formation of ethene molecule. Here carbon has 4 electrons of its outermost shell and between these two electrons uh, of carbon share with another 2 electrons of other carbon and form these double bonds. I repeat it again. Carbon has 4 electrons in its outermost shell and it shares 2 electrons with another 2 electrons of other carbon atom and form double bond. Now, triple bond. Bond formed due to the sharing of 3 electron pairs is called a triple bond. That means in triple bond, 3 pairs of electron share each other and form triple bond or triple covalent bond or simply triple bond. 3 small horizontal lines between the two atoms denote a triple bond. Here, 3 horizontal lines between the two atoms denote a triple bond. For example, formation of ethyne molecule. Formation of ethyne molecule. In ethyne molecule, each carbon satisfies one of its valencies by one sharing electron pair with one hydrogen. Here, one valence electron of carbon share with one electron of hydrogen atom, and the other 3 valencies of carbon are satisfied by forming a triple bond. Look here. Here 3 pair of electrons. 3 come from carbon and other 3 come from another carbon, from triple bonds, and this is represented by 3 single small horizontal line. This is 3 single small horizontal line. Now I am going to discuss classification of covalent bond. Covalent bonds are of two types. Number one, sigma bond, and number two, pi bond. When two singly occupied valence orbitals on two atoms overlap head to head or end to end along their axis, then covalent bond formed with maximum overlapping of bonding orbital is called sigma bond. For example, formation of hydrogen molecule, formation of uh, fluorine molecule and hydrogen chloride molecule, etc. Commonly, two s orbitals, one s orbital and one p orbital, and two p orbitals can overlap head to head along their axis to form sigma bond. Look here. Look in the figure, please. Here, s orbital of two hydrogen atoms overlap head to head and form head to head, and maximum overlapping is occurred here and formed hydrogen molecule. On the other hand, in fluorine molecule, in fluorine molecule, 2p orbital 2p orbital overlap each other head to head and form fluorine molecules, and HCl molecule is formed with sp sigma bond. Here, s orbital of hydrogen head to head overlap p orbital of chlorine and form hydrogen chloride molecule. Now, pi bond. Two atoms after formation are sigma bond. This information is very important. That is, after formation of a sigma bond, two atoms become close enough, and if they have two parallel p orbitals, if they have two parallel p orbitals with one sigma bond, then the p orbitals can overlap side to side partially. Side to side partially. This type of bond formed by partial sidewise overlapping of orbitals is called pi bond. Pi bond is weaker than sigma bond, and uh, before formation of pi bond, formation of a sigma bond is essential. The pi bond has two regions of electron density, one above and one below the sigma bond axis. One pi bond holds two electrons. One pi bond holds two electrons, and uh, two pi bonds, one is above the sigma bond and another is below the sigma bond. Look at the figure, please. After formation of sigma bond, the two atoms of the sidewise overlapping side two atoms after formation of sigma bond, two atoms, the side wise overlapping of two parallel means like this, two parallels p orbitals forming a pi bond with two lobes above and below regions of two electrons is shown. The electron density at the partial orbital overlapping remains lower. Hence, pi bond is weaker than sigma bond. Now, you have practiced everything that I have discussed today. And your homework for today is you have to prepare 25 MCQ questions from today's lesson. I think this class is very helpful for you. No more today. Stay home and stay safe. Take care. Bye.